We have Adib here, who is going to give the presentation, and also is the newest member of the Pivotal team. He'll be working with us starting next month, so very fortunate to have him aboard. So one comment though, if you don't work for Pivotal Labs, and I know there's some employees here, if you don't work here, please stay in this area. There are bathrooms right behind, but we just got to make sure everyone stays in this area. In the kitchen, of course, help yourself, get drinks or whatever. Upcoming events. So June 18th, we've got the developer advocate for the Spring team coming. He's going to give a demonstration of Spring Boot, which is a new framework. Anyone looked at Spring Boot yet? Few people? Okay, so Josh Long is coming. He's an amazing presenter. He's going to give a really awesome in-depth demo. So it's coming all the way from San Francisco on that one. So we're trying to attend that. July 30th, we're going to talk about working with Spring and in-memory data grids. So that should be an interesting one. And August 20th, we're going to do a meetup on Redis. So it's kind of like getting started with Redis, how to install it, what to do with it. So also it should be good. So there's a bit of pizza left and drinks. Help yourself. And I'll turn it over to Adib.
Thank you. Thanks everybody for being here. So tonight's presentation is about Spring 4 and Java 8. So what I'm assuming is you don't know anything about Java 8. So the way I'd like to do this is, the plan is to basically look at a bunch of the features of Java 8 and do a little bit of how does this feature in Java 8 work. So if you already know that, please bear with me a little while I give everybody else a chance to learn what that feature is. And then we'll look and say, okay, how does Spring 4 use that particular feature, and run some demo. I'm happy to answer any questions you have about Spring. Java 8, I've been a long time Spring user. Usually my laptop has a lot of Spring stickers, but my laptop unfortunately died. And I have to use my wife's laptop. So that's that part. And a couple of key facts, first of all, about Spring 4 and Java 8, which might be surprising to you. Spring 4 still works with Java 6, 7, and 8. So what that basically means, what they did in particular to make it work with 8, is when you compile your code with Java 8, you're going to end up with a class file that says for version 8. It's your own application code. There are new things in .class files, and those new things will trip up libraries like cglib and ASM, which are commonly used by frameworks like Spring. And what they've done with Spring 4 is they've made sure that all of those libraries that work with class files are fully capable of processing Java 8 bytecode. So your own code can be compiled with Java 8, but Spring itself is still compiled with Java 6. Otherwise, it wouldn't work on Java 6, 7, and 8. The reason why it's compiled on Java 6 is that they like to continue to be compatible with WebSphere, and unfortunately, IBM is still shipping JDK6. So if you actually follow this link, I don't have to turn here. But if you were to follow this link, which maybe I have to in my browser, perhaps. Apparently not. Okay, I don't have it open in my browser. If you were, it would tell you that's the thing. So the first thing with Java 8 support is, let's actually go to the first example. Can you guys make the fonts to be bigger? Could I make the fonts bigger for that video? I will.
Sure.
So one of the things that if you program with Spring for a while, you program with Java for a while, who's been like, why does Java not remember the variable names and methods in class files? Anybody ever wondered that? So you know what I'm talking about? Who doesn't know what I'm talking about? Please. So when you compile your Java code in versions prior to version 7, let's say you have a method here, public, void, do something, string, ABC, int def, right? To say you have a function with those two parameters. In previous versions of Java, it would, in the compiled code, it would know that there's a method called do something. It would know that the first parameter is of type string, the second parameter is of type int, but it won't remember that the parameter name was ABC, and that the second parameter's name was def. So that means that when you write code with previous version, let's say this was a string controller, you would have to go and use at variable. And in order to so that when you run your code after it's compiled, that way Spring would know that this first variable is called ABC. If you were doing something like add request mapping, you did something like /. And that is pretty annoying. And the only solution for it was to compile the code with debug symbols, which is perfectly valid and fine to do. That's what I would recommend you do for production Java apps. It's going to add a little bit of extra kilobytes to your jar files. It won't have any impact at runtime, really. So, but it's nice to know that in Java 8, all of the metadata around the names of the variables in the methods is preserved. Therefore, when you write something like a string controller, you can see here that I have a pattern for local date, which is going to match this variable here, local date, and I won't have to do anything special. In fact, if I go to my properties, you'll see here I've told it not to add source line numbers. I've turned off all of the debug things that the clips would normally do. Comments, questions? So this feature of Java 8 is going to help all framework writers, be they Spring or somebody else. Just happens that Spring is already out and it's capable of using this metadata instead. So that's pretty nice. You have to compile with a Java 8 compiler. Otherwise, if you're with Java 7, you just compile with debug, and then it works. But it's been formally plugged. That complaint is no longer true about Java. Anybody else? Great question. How many people here have worked with Spring MVC? I'm kind of assuming that everybody has. Who has not worked with Spring MVC before? Okay. So if you've not worked with Spring MVC, let me actually run this application. So this is, by the way, a Spring Boot application. I would like you to know that there's a main method here, which when I click run, is going to run. And it's going to launch Tomcat. So I've got my Tomcat server up and running just by running the main method here. As you can see, there is no XML. I'm not hiding anything here. 0 XML. If you're experienced with Spring and a lot of XML, you don't have to do that anymore. So let's go to localhost 8080. And there it is. It's responding with hello. This is the application. And it's coming from this controller here called example controller. Controllers are like servlets, if you're familiar with that. And you declare them. This is a new feature in Spring 4. If you haven't seen it before, it's add rest controller. So we used add controller before. The difference between add rest controller and add controller is add rest controller assumes that what you're returning from your function is, from the method, is the actual response type. And it will convert it to JSON or whatever has been negotiated via the front-end negotiation strategy. So in this example here, when I go to / with the add request mapping, it returns a string hello. That's how easy it is to stand up a REST endpoint. Now, to make it a little bit more interesting and show you one of the other features of Java 8, first of all, any questions before I continue about the controllers in Spring MVC?
Just wondering, I guess if this were not Spring body.
Yes. Yeah, you have to put at response body, which is not needed anymore. Which is kind of nice. It's also like one of the other benefits of REST controller is this. If you go like that and you go right click. So when you have a large code base, you're gonna have a lot of objects, right? And you'll be wondering, where are all my REST controllers, right? So if you have an at REST controller, you can just go references, workspace. And Eclipse will do all the searching for you and find it. There you go. These are all the places, the workspace where there's a REST controller. One of the benefits of this. The benefit of using the annotations is just really for large code bases makes it 10 times easier to find where the different pieces of the code are. So that covers the, so in summary, the first kind of area where Spring 4 and Java 8 play nice together is Spring 4 is able to use the metadata and the parameter names, therefore you no longer need to use at path variable in your parameters to control the methods. The second thing that's new in Java 8, how many people here love Java util date? How many people, if you met a person who wrote Java util 8, if you met them in a dark alley where they were being beaten up, you wouldn't like step in and help them. You'd be like, I let them suffer. They have caused enough bad karma for the rest of humanity and programmers in particular. I'll wait 5 minutes before I help them. That would be my response. So anyway, so Java util date is long been recognized as a very bad feature in Java, and it has been replaced in Java 8 with a new library, which is the Java time library. If you look at the import statement here, you see this is Java time, java.time.localDate. Anybody here uses Joda time? Okay, so if you use Joda time, what you want to know about this is that the guy who created Joda time is the same person who was asked by Oracle to kind of come in and say, can you bring Joda time into the JDK? And what was created was the JSR 310 data type, so it's local date and a variety of other things. I'll give you like here a quick overview of some of those for those who haven't seen it. Some examples here. So that you can do like the main thing about it is all the classes are immutable. You cannot change them once you define them, ever. They are not, in the Java 8 time API, there's a distinction between machine time and human time. Machine time is like how many seconds since January 1st, 1970, right? That's what you call when you get system current time release. It's very useful if you just want like an instant and time timestamp. But how do you use that to represent, some date before 1970? So if you actually look at things like local date, you'll see that inside of a local date, there's a private final year, a month, and a day. So, but all of this is what's called human time and the Java 8 data time APIs, it's actually represented as the individual pieces. Whereas the machine time is still there, but it's represented with an instant. Instant.now. So all these very nice data times allow you to do fun things like the following here. We don't want to get that. That's a nasty piece of code. Where did I put that? So you can do some really cool stuff like this. Say you have a day and you want to know when the next Monday is. You can do that with highlighted blue piece there, where you can say date.with next Monday. You say, wow, that's pretty cool, right? Doing date calculations is pretty hard to do with the old Java util date. So let's say you're like super excited about this, and you're like, okay, I want to use those, but I would like to send them into my Spring controllers. And the answer is, with the Spring controllers, you can use the @local datetime datetime format. That's an annotation that allows you to tell Spring what is the format of the variable that's coming in. So if I send a request to a URL that looks like the following, /date, / say 2012-02-01, something like this, Spring will automatically know to convert from this string to an actual local date object. So you can start using those nicer libraries today. In fact, if you're still using Java 7 and you want to use those, one of the things that you can do is, I don't have internet here, there's a JSR 310 jar file. Because this was built in an open source fashion, this jar file has all of the code that's in the JDK, but it's packaged as a jar file that you can drop into any existing Java project, including Java 5 and 6 probably. So you can start using those today, and they will work with Spring. So let's try this out, since we've got the server running. So if I go here to /date, / say 2011, yeah, you can see it prints out. But the controller doesn't do anything there other than it just returns local date, not toString. Just wanted to show you that you can use it. Comments, questions? Okay, so everybody's going like, yeah, but that's not the interesting stuff in Java 8, right? The interesting stuff is the lambda expressions. So let's see where we are on that. Right, okay, so that was one piece thing. Another kind of really cool feature in Java 8 that's really easy to understand is repeating annotations. How many people here have used JPA before? How many people have put at named query? Used that before? How many people have been like, why do I have to stick them in an array? So let's see something that is illegal in Java 8, in Java 7. Look at this. So in Java 7, you are not able to take the same annotation and repeat it more than once. And in Java 8, that's perfectly legal. So one of the things they've done is they've used that feature in two locations in Spring 4. One of them is with the property source. And what the property source does is it basically tells Spring that, hey Spring, while you're booting up, what I'd like you to do is read the content of these property files and make them available through the Spring environment object. So in this example here, at boot up time, you can see I'm just using the environment to read those properties. And if we look at the console, I can prove to you that they're there because it prints out prop1 value, prop2 value. So that shows you that feature works. Comments, questions about that? Are you going 8? I know you want to JPA. This is actually, the reason why they can actually even do this is that it's in how they implemented it. So let me show you how it's actually implemented in Java 8, that particular feature, in case you want to do it for your own code. So if you don't have it, the way you would implement something like this is you would have like an array of the annotation, and you would have a container type. And they said, well, if we go and we just change things, then all applications that are using JPA and Hibernate and all different frameworks will completely break, and we don't want that to happen. So why don't we just formalize the pattern that people are already following? So when you look at the @schedule annotation here, you can see that it's got an @repeatable. See that? And it says if you see two multiple @schedule annotations, take them and stick them inside of the schedules. And inside of schedules, you can see it's got the annotation definition. It's got an array of schedules. So what that means is that when you have, let's say you have some service here that says @schedule frequency hourly, @schedule frequency monthly. I don't know why you would do hourly and monthly, but it's only a quick example. You can get at that information. If you run this code here, you can go and say to Java, give me all of the annotations of type schedule, and we'll give you back an array. This is Java 8. So this line here is new in Java 8. You can't do that in Java 7. However, if you have an older framework implemented with something like Hibernate or whatnot, it's going to be calling the get annotation method. And because it doesn't yet know about this get annotations by type. Or maybe you want your framework to work with previous versions of Java. For example, Spring 4 is compiled with Java 6, and it's going to need to, like you don't want it to be calling a method that only exists in Java 8. So they can just call get annotation, pass in the container type, and they'll get all the repeating. Who's looking at that? Any questions? So this just one of the really nice little things that they added. Yeah.
Sorry, so I can go back.
To the
yeah. So I think if I'm inspecting some code which I don't know the annotation is repeatable or not, with the get annotation by type, then if possible, we'll return array or a single object.
Yeah, it will always return an array, but it will be an array with one item.
If I don't know, I just want to inspect it. So I try to get something returned. But when I write this line, I have to know this is a repeatable or not.
Yeah, you can tell that though, because look, watch what happens if I delete this line.
So I think that on the bank, because I don't know it's repeatable or not.
But you do when you write code, because you can look at the annotation. If you are like completely introspecting something, you could look to see if the annotation itself has an annotation on it called repeatable.
If it defines some words, repeat some words, just a single.
That's fine. Get annotation by type will work even if it's a single one. You're going to get back an array, and the array will have one item in it. Does that make sense to you? Yeah, like, it's perfectly fine. If this was like something that you could only have one of it, you can call get annotation by type, and it says, here's an array, it just has one element in it.
Yeah, but that's not my question. My question is if I don't know it's repeatable or not.
Who doesn't know? The person that's parsing the annotation doesn't know?
Yeah, the parser.
Well, that person can call, if they don't know, then they're going to basically call get annotation. And they're going to treat it as if it returns one item. But notice that when I call get annotation, look what I'm calling. I'm calling schedule with an S. So if you were designing something that needed to have multiples of the same annotation in versions prior to 8, you would have had to create another annotation to contain the instances, like add named queries and add named query.
Okay, now I have an example. For example, if I make a automatic code checker, so that just automatically to grab something and to pass the code. But that case, the developer will don't know what the code will be, to work for. So
The developer that's using the annotation?
yeah, if the programmer is going to check the code and to pass all to check out all the annotation. So,
Yeah, so if an annotation is repeatable or not, it's going to be part of the documentation of that annotation. Worst case scenario, you just go to the code and you see that it has repeatable, and that's how you figure it out. So if you know the code was built and designed before Java 8 was out, then it for sure doesn't do repeatable stuff. If it's a version of a library built where it claims Java 8 support, then perhaps some of those annotations will be repeatable. By default, annotations are not repeatable. They're only repeatable if you stick repeatable on them.
Well, it doesn't support repeatable. The compiler itself won't compile.
Yes, that's right. You'll get a compiler. That's correct. You can see that there. It was just my machine is a bit slow. Okay. So we can talk a bit more about it if you want offline. Okay. So it covers the repeating annotations. And so both the repeating annotations and the the compiler remembers variable names are two good examples of how Java 8 is kind of helping you out there. And Spring is already able to use those two things. So the next thing we want to take a look at, just to solve PowerPoint, we did the fine. So lambdas, right? The main thing. How can we use lambda expressions? So how many people here have looked at lambda expressions in Java 8? Who's not looked at that before? People? Okay, so let's take a look at some examples. And let's spend a few minutes on that. The thing about lambda expressions is you want to think about them, first of all, what are they? They're like anonymous functions or anonymous inner classes. Who's familiar with anonymous inner classes? You can think of them as anonymous inner classes, but they're not quite the same because there are things anonymous inner classes can do that lambdas cannot do. And there are things that lambdas can do and that anonymous inner classes cannot do. For example, lambdas have very compact syntax. So in this particular example here, we've got a list of 5 integers, and we call the for each method, and the for each method accepts a lambda expression. Think of it that way. And in this case, our lambda expression is a function here with one line. We're going to say x arrow system.out.println. And if you run this, it's going to print out 1, 2, 3, 4, 5. Now, there's a lot of different ways to make the syntax more understandable. Let's take a look at something that will make it more like a function. If you look at this example here, same exact program, except the only thing I've done is I have defined this part here. Does that look to you like a regular method signature? Type and then variable name. And then before that, usually if it's a real method, you would have, what the return type is, and you would have the name of the method. We don't need to specify what the return type is of a lambda, because it's implicitly where it's being assigned to. So the for each method is expecting something of a specific data type, and it's assumed that the lambda expression has that data type. And because it's assumed that the lambda expression has that data type, the compiler can automatically infer what the return type is, so you don't have to actually type it. And then the rest of the lambda expression, as you can see here, is just curly braces, and here's your block of code that does that. So in order for this to be understandable, if you're probably wondering what's the data type. But before I do that, I'm going to give you another reference. I had the fortune of being able to do almost a 2-hour presentation at the San Francisco JUG on Java 8 lambdas and streams, and that's videotaped on YouTube. And I go through all of the features of that. It's very easy to follow because when I put the presentation together, I had one rule: no clever examples. Because I found a lot of the other videos on Java 8 were always showing you off how powerful it was, and they use very clever examples very quickly, and then you would lose. It was too much too fast. So if you want to kind of get that, just Google for Java 8 lambdas and streams. In Google, click the videos button, find the first link. You'll see my picture in the little icon, and that's that. Yeah. So the way that lambda expressions work is they get converted into a functional interface, effectively. And I want to kind of explain to you what a functional interface is. I'm kind of giving you here the super crash course before we look at the rest of the details. And a functional interface in Java 8 is an interface which has one method. So take a minute to read this just to. So when you look at this interface, does that look to you like a lot of interfaces you've seen? Who's written an interface with a single method in it? Who's seen other people write interfaces with a single method in it? Everybody's answered yes. If you have an interface that has a single method, Java 8 will consider that to be a functional interface. And you can also see that there's this new annotation, add functional interface. And this annotation, I can delete it, and it's still considered by Java 8 to be a functional interface. What makes something a functional interface in Java 8 is the fact that it has a single method. That's it. And when you have a functional interface, Java is able to take a lambda expression and convert it into something that is of the same type as that functional interface. So if you have something here with, if we take two of these, we put another method on here, that the minute I do that, it complains that this thing is no longer a functional interface. So my point of explaining functional interfaces is if you have a piece of code written in Java 1.0, which takes a parameter that is an interface with one method in it, and you compile it with a Java 1.0 compiler, and you bring it into the world of Java 8 without recompiling that class file, you can pass a lambda expression where that interface is expected. Who's with me on that? That's how they preserve backward compatibility. When they were building Java 8, they said, okay, we can introduce a new function type, and if we introduce a new function type, then lambda expression's data type will be that function type. But if they did that, it was going to cause enormous problems with existing code bases. It was going to break backward compatibility, and so they decided they don't want to do that. And it's good. Well, whether this is more straightforward or not wasn't really their concern. Their concern was not to break backward compatibility. So other languages that were designed with lambdas from day one have the concept of a function type. So what this means is, if you look at, in the context of Spring 4, is Spring has a lot of existing functional interfaces before the word functional interface was invented. And that means that without any changes to Spring, you can just start passing lambda expressions to a lot of the existing things that are built into Spring. So I'm going to demonstrate that by actually converting some code that is written using Java 7, effectively idioms, to using Java 8. But I want to see if anybody's got any questions about lambdas at this point. I know it was a crash course.
About jumping. So how do you implement like a concrete implementation? Does the concrete implementation implement this interface? Can I have multiple topic methods?
No.
Or no, right?
If it's a functional interface, the short answer is you can have only one method, unless it's a default method. There's catches. Let's just say that there's a lot more than I'm actually telling you. So for example, let me show you something that you probably have not seen in Java before. There you go. That's a new, you can see the keyword default. That means that this is a default method. I don't want to get into all the details of that. Watch my YouTube video. You can get, there was a very good crowd that asked a lot of questions. So that's in that video. But the important thing for our purposes is that all code, even compiled with 1.0, can be used with Java 8. So in a way, you could say that because Spring was designed with these functional interfaces from day one, they had to do nothing to be able to say, other than update the class byte format handling that I was talking to you about earlier. That was probably the biggest change they had to do internally to make it work with Java 8. Yep. Yeah, you can call those methods, and they will run. Yeah. I don't know exactly what you were doing with them, but they have certain rules that they have to follow, and yeah, again, it's yeah. So I want to make sure I get to the next. Well, we're kind of the last part of the presentation. Does anybody know what time we started? Do you know?
We started about 10 after.
10 after? Okay. So I'm aiming to finish in the next 10 minutes. That's okay.
You can have more time.
I would let people decide if they have more questions.
Yeah.
If they have more questions, we'll get into that. So let's take a look at P6 right here. So I've got this example repository. And it's just a regular Spring component. It's auto-wired in a JDBC template. I've got a variety of methods here that use different features of JDBC template. So for example, you can see this execute with a statement callback. And this is doing it with the way you would do it in Java 7, which is to pass in an instance of that interface using an anonymous node class. And what I want to do is convert some of this code to use Java. And you'll see in the process of converting it just how easy it is to do and how much more compact it will be. And the fact that they had to change nothing in the implementation of Spring. It just passed the limit. What's the good way? Let's actually first show you what this does when I run it. So I put it on this URL here, repository. It says check the Eclipse console. And what it does, it just runs all of these. So there's a bunch of tables in the database with some stuff in them. So for example, this is the products table, the product one. There's 11 of it, 1199, right? So let's take that, if we make the changes to lambdas and we still see this output, then everything's still working. That's what it means. Let's start at the top of this class and take a look to see, can we use Java 8 with some features? So if we look at query for object, the query of the JDBC template, for example, query for object takes a string, which is the SQL that you want to execute, plus an instance of a parameter source. So in this case, I'm actually just calling the object. I'm not defining a new instance. So Java 8 doesn't really add any value here. We can skip this example. You do the same. This one is an update where it's just like a single item, and doesn't matter. Doesn't have to Java 8 there at all. Simple insert. Well, we're going to execute and return a key, and we're going to pass a map. Well, a map is not exactly a functional interface because it has more than one method. So you can't really use a lambda expression there. All right, execute and prepare statement. Aha, something where we can do that. So you can see that this execute method, let's first take a look at the signature. Notice that this execute method takes two Java interfaces. Let's take a look at the first interface. Does this interface have a single method? Yes, it does. What does that mean? It's a functional interface. Therefore, I can pass in a lambda expression. Similarly, we look at the second one, prepared statement callback. How many methods does it have? One. Is that a functional interface? So who can see that? I mean, does it have add functional interface on here? No. Why does it not have add functional interface on here for bonus points? 1,000 bonus points. Yes.
It's not Java 8.
That's not Java 8 code. They're compiling Spring with an earlier version of Java. Yeah.
I was trying to use simple JDBC and it said it was deprecated.
Yeah.
I think the JDBC template was said it was deprecated. So it's deprecated. What do you use?
Okay. Well, so you're asking specifically about the deprecated feature on it. That was probably been removed from version 4.
Yeah.
If you were playing with an earlier version. Deprecated method means there's a better way to do it. So when you run into something that says deprecated, there's usually in there something like @c also. You got to go to the @c also, and there's usually that thing is always better than the thing that's deprecated. There's a reason why. Deprecated is just a hint to you, the developer. This is an old way of doing things. We made a mistake when we created it. We would like to remove it in a future version. So if you have code that you've already written, prepare to change that in a future. And if you're writing new code, don't use deprecated methods. So let's go back here to the example repository. So you can see here that there are two parts to this. First part here that I'm highlighting is the prepared statement creator, and the second part is the prepared statement callback. So what I can do to convert this into a lambda expression is delete a lot of code. So I'm going to basically say, okay, I don't need the new stuff because, well, that's not required. You don't need to define an anonymous in a class. It's a lambda expression, so it doesn't need a name. It doesn't need a return type because it's going to automatically infer it from the parameter. I don't need to give the method a name, so I can delete that part. And I can then say, well, the lambda expression takes one parameter of type connection. I don't need to put the throws statement because that's implied. And there you go. I have an extra curly brace I need to delete. Right? As you can see, I just saved the file with no file. It was like, wow, cool, yeah, I got rid of that's awesome. But we can get rid of more. We can get rid of more. We can get rid of more, a couple of things. One is, you don't need to specify the type of the parameter. Because it's a functional interface, there's only one method that's implemented. And this lambda expression's signature must match the signature of that method. Therefore, the first parameter is going to be of type connection, so I can get rid of that and just call it like that. Another thing that they decided to do is it's going to be quite common that you write one-line lambda expressions. So if you're going to write one-line lambda expressions, yeah, this has got like a curly brace, a return statement, so you can do this. And get rid of the semicolon. Yes, the Java 8 compiler. So there you go. So I could kind of go like this and try to, if I wanted to, I'll flick it on the screen, but you can see quite a lot of deletion of code. So one of the things of using Java 8 is you find the code will be a bit more compact than it used to be. So let's actually run this and check that it still works. So we'll stop this here. Let's clear whatever is here so we can see the output of this thing. And we'll go and refresh that. Go back to Eclipse. And there's our output. Hey, it still works. No exceptions, no errors. Okay. So, yeah. So who's like, okay, so all of this cool stuff here had nothing to do with Spring. It was just Java 8's backward compatibility. The thing you got to give Spring as developer credit for is they had good, like things like JDBC template, JMS template, all of these template classes that are built into Spring just naturally could use this style. So that's that part. Let's convert the other one. Right, so again, this one here, say we want to convert it. What we do is we just take this big declaration here. We no longer need that. Delete that. Delete this line. Delete this stuff right here. don't need any of those close declarations, get rid of those. So in this case, we have more than a single line, so we will want to, I just need to get rid of this extra really place down here. Oh yes, I need the arrow, thank you. And there we go. And of course, I don't really need the prepared statement. I can just go back up. Yay! Yay, Java 8.
How do you say that to yourself when you're saying it?
Sorry?
You know, when you're saying this out loud to yourself, how do you pronounce it?
You mean when you read, if you're reading the code?
Like the first one. You go con, what do you say?
All the templates method. Here's the lambda expression.
Thank you.
Yeah, here's the lambda expression that takes it. In fact, if I was doing it this way, I wouldn't call this con. I'd call this connection. Because then the name tells you more of what it is. And this one here, I would call it prepared statement.
Why would you spell it?
Because I cannot spell. You have not noticed that by now. My brain does not see transpose things, which is why I never became an engineer. And that's why I very much favor languages like Java that have nice tools like Eclipse that can, even though when I type something, I never read the code. I just go dot, tick, 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 tick. I just only see bits of the code. In all the previous jobs I've had, there were very famous comments that in history, correcting Adib's spellings. If you ever see that in a code base, you know how to work that. Yeah, there's that.
What's that error?
What's the error? Let's actually see what the error is.
You already changed
a
one.
reference on connection.
Yes.
I think that's the default.
Erasure. Erasure. I think problem here is let's just go control I and see if I can fix it by just doing a cast. We do non R. I should have tried this before live coding it here. Yeah, it should. Oh, there's something else here that I'm missing.
Do you need to pass the second parameter with the statement bracket format?
Which second parameter?
We wrap it.
No,
One more guy. One more guy.
Yeah, put one more back in.
Where?
Make like class to return the second parameter with the generic object.
With the type parameter.
Go look at the execute. Look at the error message again and execute.
No, it's saying it's ambiguous.
It's saying object. It's saying compared to an object. Then the old stuff. You compare asset to compare state and then product. Right there where you're supposed to be.
No, because that's an interface from J2C, right? So there's probably a method in there where it's not able to tell which one to select based on, let's go here, there's a type ratio, most likely, see if I go click on it, it's not even able to pick up which method on template to execute. It's interesting, I wish I actually tried doing the second part of this before I live did it here. And
Do you have to cast the return from the lambda? Or
no, I don't think it's that.
Okay.
Yeah, let's do that. It's, yeah, it's probably most likely having trouble distinguishing between those two. Is the callable statement a creator and the other one related to each other? Yeah. We don't, I can try that. I haven't tried, so Java 8 is still new. I'm experimenting with it, like everybody else is out there. Yeah, I hope this is not a bug in the Eclipse beta version of Java 8. Oh, now, actually, yes, you're right. Yeah. Oh. The problem here is this is what calls product 2. It's just getting confused because two things called product and the landing expression outside. So they're able to capture what's getting in the way. Yeah, there we go. Cool, who asked that question? Where the error was. Thank you very much. Made me sweat a bit, but
Well, it's because
I had not tried casting a lambda expression before, and that works beautifully. Look at that. Cool.
I was wondering, did Java did anything to the type erasure? It's just so weird.
No, type erasure is still there in all its glory. And there was a survey from Oracle a while ago about what should be done about that. Do we want to fix it? Is it too late? I filled out and said, yes, fix it, but I don't know if they're ever going to. But one of the things about Java 8 is they really, about Java in particular, there are trillions of Java lines of Java code out there. And the experience of Python breaking backward compatibility between Python 3 and 2 has been so bad that I think most language designers are going to be like, if we break backward compatibility, it's a really bad thing. At Java 1, I went to the session that was Meet the Language Architects, and people were asking things like, if you could reinvent Java, what would you do? And they'd say, well, we have Scala. Scala is like Java 2.0. So it's quite possible that erasure will never be fixed.
Well, Scala is still affected by erasure.
It is, but yeah, we'll wait and see if they ever do that or not. Maybe 9, maybe 10, who knows. So that covers that part. Now there's a few more examples here. I'm not going to go through them. I hope you get the idea of, if you see a functional interface anywhere in your code and you're writing Java 8, you can just pass in a lambda expression as expected. Some of the more exciting features of Java 8 have not shown up in the APIs yet. So I'm just going to take a couple of moments and tell you, if you could redesign JDBC, for example, and you had Java 8, what kind of new things would you have? But before I do that, are there any questions about Spring 4 or Java 8?
I have a question. But
Sure.
I say that
No, go ahead. Ask a question.
Can you quickly go back to the example that showed the first lambda instructions? Yeah. I'm just curious, right? Because I do quite a bit of the style too, and I'm just curious on that particular lambda. So this, So the one example where you have so x arrow and then x plus something. For each, the one with the for each, and then x arrow.
Yeah, you mean when I was accessing variables?
This here, you are the integers, that variable.
Yes.
It's mutable, right?
No, integers is a list. It's mutable. The mutability rules, okay, I know what you're talking about. I'll show you I think I understand your question, so I'll just show you this guy right here. This is what you
So how do I spit out a new collection without affecting the original? Because here it's actually...
You want to do streams. Streams is what you want. So with streams, what you can do is, let's put the stream example here, say collectors, let's try this one here. So here's my list of integers. And all that this is doing is making a new list. It's streaming it out, and I'm calling collect, and then putting it into a new list. I'm just explicitly, painfully specifying everything out there. So the streams API is there. It's not going to be anywhere near as compacted as you can get with Scala, because it still has to live with the limitations of being backward compatible. But what it does do is it is good enough, and it's here, it's backward compatible, and that's hopefully going to cause people to upgrade and do that. There are a lot of Scala is a really nice language, and I love when I write it. My favorite feature about Scala is going to sound totally trivial, but I love the fact that there's value and depth, right? And everything aligns. It's vertically, the very linear align. That's my favorite feature. Forget type matching, all the other cool. That's my favorite one. So. Yeah, but it's like how you define the variables and the values. You go val something. It's more than 3 characters, right? So it's always perfectly aligned. Yeah, that satisfies that part of it. Yeah. Which example? Example.
So here I have a question. So that normally with this, that means that Java create the errors probably will be lower than the case, right?
You mean the problem when I have that?
No, not here. Here, I mean the arrow, yeah, the first line. The arrow's power.
Can you tell me the line number?
Yeah, 97.
Yeah.
This one. So that in the case, the priority will be higher than the arrow operation. Or,
You mean talking about the cast here?
yeah.
No, see, so basically, let's think about it this way,
I
right?
think it casts the first, then
This thing right here
yeah.
is going to generate, almost think of it as generating the anonymous inner class.
This
Yeah.
will return a product class. But you can case if the arrow's priority is higher, then you cannot.
There's no priority there. There's no precedence or anything like that.
No, I think it should cast priority.
I don't think.
There's two operations. One is the arrow, I don't know how to call it,
Sure.
lambda operation, I don't know. The other is case, right? So that must have one priority higher.
Think about it this way. Let me actually explain to you how lambda really work underneath the hood, and I think it might answer your question. It's a two-stage life cycle. And the first part, a lambda is really converted to a static method. So let's go take a look at our first example and explain to you a kind of sort of syntax example here, and I'll tell you how the compiler can actually do it. So imagine this. No, sorry, not this. Okay. So imagine this thing right here. You can see that that static method does the same thing as the body of the lambda expression. Does that make sense to you? Now, if you have this thing here, imagine that the compiler goes around and internally on this line right here, it's going to create an object dynamically using invoke dynamic, which is the instruction set in this Java 7 VM. And that invoke dynamic is going to turn around and call the static method.
Right, but here we have to case.
Case of what?
The return value. There's no return value.
In this, sure, that's fine. So why is it? If there was a return value, then this would have been, let's say, integer, right?
Right.
Yeah, let's say it was taking x plus 1, right? Return.
But that's reasonable, and the function, the static function will be evolved first, and then the parent function will do the case later after the return.
Well, think of the lambda expression as defining the body of a static function, where all of the parameters to that static function are whatever you access inside of the lambda expression. So if you accessed, let's say, we go here to the
Right, so yeah, actually, I just want to know
Okay.
the power increase.
There is no priority because the lambda expression, lambda expression is done at compile time. There's really.
Okay, let's think about this. If we replace the Java code by the regular Java code, you can then, for example, we replace the arrow by dot function, dot method. Then you want to return something and you do the case. You have to put bracket because it's the case the priority normally is the lowest. It's lower than dot.
What do you mean by case? Like the case keyword?
Cast.
Cast. Okay.
Sorry.
Okay.
Yeah.
Sorry, I was getting confused. Okay.
The cast word is normally the lowest one. So lowest, for example, we replace the the arrow by dots, and we call.
So the compiler basically looks at this and says, here's how the compiler thinks. It sees this expression right here, and it converts it into an instance. Think of it as an instance of whatever that parameter is. It has a type. This highlighted blue code has a type. The type is the same as the functional interface. That's the parameter. But because there's a conflict, the type of that lambda expression is actually whatever we're casting it to.
Can I take a question?
Yeah.
So when the compiler sees this, right, when it sees the arrow, it actually sees the part before the arrow and also the block in the braces as one thing. So it resolved that first before you do the casting. Your question is, well, would the cast actually affect the prepare statement PS first? No. In this case, because the compiler see the one that is highlighted as one entity. Yeah, so we resolve that first.
I see. I just want double, to confirm this. Yeah. Right. So because normally if we don't put the number here, maybe if there is an instance and we call method after instance, and if you want you have to put a bracket if you want the right. So like okay.
So when you say what's a lambda, that's the entire thing. It's a lambda. It's not breaking into like one part with a method signature with the brackets and like prepare statement PS, and then you have this little block of code. It's not. The entire thing is a lambda. So it's just casting the entire lambda into that type. So you don't break the two parts. You don't say, well, that's a method signature first, and then you have an arrow, and then you have a braces. It's not. The entire thing is one thing. And then you have that.
Okay, so you guys, maybe we can take this one off, right? If you don't mind. We can draw some diagrams and talk about that. Are there any other questions? All right. So there was one final thing I wanted to show you real quick. It's a feature of Java 8 that Spring does not use yet, and that is new features in concurrency. There is a completable future. Completable features like promises and JavaScript. Got it. So if you're used to there's the future interface in previous versions of Java, and the future interface, the only way for you to get it was to go and create go to an executor, get something, you get back a future. With Java 8, with a computable future, you create the computable future completable, not computable, just with a new. And then you could start up any number of threads. When you call complete, anybody blocking on a get on that future gets released, just like promises in JavaScript. Okay, so that's all I have to say. So I hope this was, you got to see that you can start using Java 8 with Spring today, and yeah, I'm sure future versions of Spring will have more support for Java 8.